For this problem, we're going to take a look at three fatty acids and try to determine whether or not they're saturated, monounsaturated, polyunsaturated, omega-3, omega-6, or omega-9. Now, saturated, what does that mean? Saturated means that you cannot add any more hydrogen. And so really what we're looking for there is double bonds that can be broken by adding hydrogen. Omega, you may have heard of omega fatty acids or omega fats. And for a while there, that was kind of a health craze saying that getting omega fats from sources like salmon were supposed to be better for us. So we're going to take a look at what does it mean for something to be an omega fatty acid. Okay, now saturated, monounsaturated, polyunsaturated. We're looking for double bonds. Now this first molecule here, this first fatty acid, we've got a carbon followed by 16 more carbons. And we just put the brackets and the 16 there because we're lazy. And then a carboxylic acid here. So there's a total of 1 plus 16 is 17. That's 18 carbons. There's 18 carbons there in this fatty acid. There's no double bonds. So we would call this one saturated. Saturated. Now, we don't add the term omega because omega tells us where the double bonds are. So for example, this molecule here, we can see that there are double bonds. And this double bond here happens to be, let's see here, 1 plus 4. So that's 4 plus 1 is 5 carbons. And this here becomes the 6th carbon. So I'm just going to put here that this here is our omega 6. Because it's our 6th carbon. And then if we continue on, 7, 8 carbons. And then there's 2 of this whole structure here. There's 2 of these whole structures there. And so if we repeat that, if we do that again, then we're going to have another one at, let's see here, there's 6, 7, 8, and then repeating 9. So this is going to be omega 6 and omega 6, omega 6 and omega 9, omega 6 and omega 9. That's just saying that the double bond is on the 6th carbon and the 9th carbon. Okay, and so is this saturated, unsaturated? Well, we've got double bonds there, and there's actually 2 double bonds. There's one here, but because we have a 2 here, everything in the brackets is times 2. So this one here is not monounsaturated, it's polyunsaturated. So I'm going to call this one here polyunsaturated. Polyunsaturated. And then this last one down here, we see double bonds, okay? And let's see, there's how many of them? It looks like just one double bond here. And so this one becomes monounsaturated. Monounsaturated. And where is that double bond? It's on the 1 plus 7 is 8, 9. So it's off of the 9th carbon. So this is going to be omega 9. Omega 9 fatty acid. Now when we write this out, we have special nomenclature for this when we have these omega fatty acids. So first we're going to write out how many carbons there are. So the number of carbons in this first one here, we've got 1 plus 4 is 5, plus 1, 2, 3 times 2. So 3 times 2 is 6. 5 plus 6 is 11, plus 6 is 17, plus 1 is 18. So there's 18 carbons here. So I'm going to go 18 carbons. And then we're going to say that we have two of these omegas here, 2 omegas, 2 double bonds, and they are off of the 6th and the 9th carbon. So it becomes 18, 2, omega 6, and 9. This is the name or the shorthand for this particular fatty acid. Now this one here, down below here, we're going to count up the carbon atoms. So here we have 3 plus 7 is 1 plus 7 is 8, and then 9, 10, there's 10, plus 7 is 17, plus 1 is 18. So this one becomes 18, and then there's only one double bond there, so we don't have a 2 there. So 18 omega 9, 18 omega 9. So that's the shorthand way of writing out this particular fatty acid. For this problem, we're going to take a look at two fatty acids and try to identify which one has a higher melting point. Now, before we do that, it's going to be helpful to see the actual structure. And what we have here is just the condensed formula. So we're going to have to translate the condensed formula into the actual structure. Now, I'm going to do like the zigzaggy line thing, but I need to know how many carbon atoms I'm talking about here. So this is a 1 plus 5, that's 6 carbons, 7. So this is an omega 7 fatty acid. So there's 7, 8 plus 7. 8 plus 7 is 15, plus 1 is 16. So this would be here 16 omega, 1, 6, 7, omega 7. 16 omega 7. And now I'm going to try doing the zigzaggy thing here. So I'm going to go like this. I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Like that. And then I have my double bond. Bond like this. There's my double bond. And then now, after the double bond, I'm going to have, let's see here, 1 plus 7 is 8, 9. I'm going to have 9 carbon atoms, and they are trans. So I'm not going to go up like this. This would be cis. So I'm going to have it come down like this, like that. That's going to be trans. And so here I have carbon number 8, 9, 10, 11, 12, 13, 14, 15, 16, like this. Okay, so 8, 9, 10, and then so on. Now, here, this is my structure. Now, if I were to compare that to this one here is cis. Now, this is the same formula, it's just that it's cis. So everything is the same. I'm going to go 1, 2, 3, 4, 5, 6, 7, and then I'm going to go double bond like this, okay? And then I'm going to go cis, so cis on the same side here. So this is 1, 2, 3, 4, 5, 6, 7. Here's 8, like that. And then after that, I'm going to put the rest of mine in here. So there's, let me see here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Carbon, double bond O, H, like that. Okay, so here's my two structures. And then this one here would be, again, 16 omega 7. But this one here is trans. And this one is cis. Like that. And back to our original question now, which one's going to have a higher melting point? And the higher melting point is going to be this one here. And how would you know that? Okay, well, unfortunately, it's just one of these things that we're going to have to remember, is that trans molecules like this, these can pack a little more tightly. In other words, they can stick to each other a little bit more. And if they stick to each other more, that's going to be harder to pull them apart. And so this one is going to have a higher melting point. So I'm going to say this one here has a high melting point as opposed to this one. And all that has to do is just the fact that these ones here just pack closely together as compared to this one.